Good morning, fam. My name is Kelvin. So yesterday we spoke on this media, yeah, and I want to take that privilege to come today as well for us to look at something. So I've come across a comment that someone was asking if he doesn't have the components, what does he or she do to also start his journey, his Arduino journey. So I can recommend a website for you called Tinkercad. Yes, Tinkercad is a very good website that I believe can help you start your Arduino journey if you don't have the component. So when you go onto your browser and you search Tinkercad, Tinkercad, yes, I think, and you click on it, the first one that shows this is your Tinkercad. So you follow the procedures to create your account, and you just simply scroll down here, circuit, you can build your own circuit, and then there are templates too, so that you can also select any of those templates. So simply to build a circuit, you just drag and then drop the component there. You can zoom in and out as well. And let's say we are building a simple LED that should switch something like this. Yes. So how do we connect this? We know this is the positive and this, and send it to the negative terminal, which I believe is, and then drag it somewhere here. I believe here is fine. Then we connect it onto the terminal there. Yes. And then we do same for the positive. Connect from here. Let's bring it out a bit. Then we take it right along the line, maybe somewhere here. And then we bring it to this side a bit. And then we connect it onto the positive. So when we simulate this, we should have the LED on. Yes, so we have the LED on, but this is a wrong approach because there is no resistor to reduce the voltage. The voltage is quite high. Those of us who understand what I'm saying realize that the voltage is a bit high. That's 9 volts, which is quite high for this resistor. So you can see that simulating on this app gives you a reality, or the reality on grounds. Yes. So you see, when we've simulated this, you can see that it's showing something like an alert or alarm sort of thing. So you simply simulate your projects here, build them before you can also build the hardware, the reality or the real world scenario, so that you get to avoid some of the mistakes like this one, burning your LEDs and other stuffs. Imagine buying an Arduino board for almost 70 cedis or 80 cedis, 80 Ghana cedis, and then it just gets bent just because of a little error. That's very painful. So you get to simulate it here. You see errors, then you correct them. Let's say by mistake we find ourselves um, we've connected this point of our connection our system to this. I'll have to stop the simulation. So let's say we've mistakenly connected here, then bring it here to here, and we are not aware of it yet, and it has a problem. So let's see if we simulate it, how that would come out, how that will look like in our system. So let's simulate that. So let's see what happens. You can see we have started simulation. You see the LED is not on. The LED is not on. That means if you wire this, if you put or you build this, it will also not on. It's either the battery will have a short circuit or something. So if we were to use the Arduino instead of this, you would clearly understand what I'm saying. So let's use the Arduino to simulate this build that we've just done. Let's use the Arduino to simulate it. So let's use the Arduino to simulate this build. Sorry. Undo. Let's use the Arduino to simulate this. We are taking this off. Now let's drag our Arduino and then drop it there, quite somewhere here. Then we'll pick ground for this. We'll pick, let's say maybe 7 to this. And let's write a very simple basic code, right? So let's write a very basic code. So in the codes too, we have some of our programmers who are good at Scratch, but not good at writing the code. So you can use a Scratch as well. instead of using, the blocks, instead of using the basic Arduino code. So for you can also use both if you are not really sure. You can use both. We have an existing code here, which is just a preset type one that is available. Let's see if we can do some few edits in it, then we can be good to go. So over here we'll be using 7, right? 7. Okay. Over here we're using 7. Take this off and let's see. Why? Let's see. Let me take off these blocks. I think that's where the reason, where the problems of these blocks. Putting smart. Um, code. Okay. Real monitor. We need that. Now, just we need. Okay, so let's go back to code, and we are going to be using text. Yes. So over here, let's change this to 7. Okay, we are making this 7. 7. We are making this also 7. 7, and we are making this to 7. Yes. So let's run that, and then let's see how our code turns out to be. Okay. So we have it on, but because there is no resistor, you can see it's showing us that there's an error, right? So let's try putting the resistor to see how that also turns out, right? So let's first stop the simulation, drag our resistor somewhere here. We can rotate it to have a very good angle, which will make our work a little nicer. I think I've rotated it too much, so let's just undo it, and we'll come close inside, and oh shit, let's undo this, undo this, undo this, undo that, and then we are going to take this off. We're going to take this off, and we will first connect it from here to here. Take that off. Good. Then we will have another point from here, then down to ground. Okay, that should have been on this side, but I think you can understand. Okay, then let's pick this up. So now let's simulate it again and let's see what we get. Okay, so I think now we understand what's going on. Because of the resistor, I think that there has been a resistance in the current. So you can also reduce the value of the resistance to make it much brighter, right? So let's make that milliohms, and let's see. Means it's still low, right? Very, very perfect. So it means one. So that is basically simulation, and we are done. Thank you guys, and see you in the next video.